Hey, thank you. Good morning, everyone. I am one of these passionate people. Thank you for pointing that out. I love the products I'm building at AxonIQ, and I'm going to do this presentation with two of my colleagues who I know to be very passionate as well. Like they said, Stefan Dragisic and Stefan van Beelen. They will make an appearance later. But first, I have no more slides. I wanted to tell a short story. Last year at the conference, I wanted to talk to everyone because I wanted people to tell people, I have sold my house, I'm going to be a digital nomad, I'm going to go out into the world. And they were like, where do you go? For how long? And what do you want? I said, I don't know, and I don't know. Well, I do know the answers now. I wanted to go to Gran Canaria. The time I've spent traveling has been less than one conference cycle, because right now I am moving to Spain because I found a place I love and the girl I love, so I'll be moving there. And one of the things I noticed about the difference between Spain and the Netherlands is that in the Netherlands you get stopped on the street for donations, for subscriptions and stuff like that. In Spain, whenever I go to the Corte Inglés or a similar store, I get stopped to do an inquest, an inquiry. A poll, basically, like, why are you here, or where do you travel to, or what products are you buying? So I thought that would be a nice experiment to get some of Spain here. So I would like a show of hands if the following question for you is true. Who here has made an account on AxonIQ Console? Thank you, guys. That's amazing. Who here liked AxonIQ Console? Thank you as well. So, who of you believes they are an expert on AxonIQ Console? Of course, I hope you are. You developed it with me. So, what I want to show to you today is not a regular demo. What I want to show to you today is how we can fix a broken Axon Framework application. So, I pulled an old Axon Framework application out of the closet and I updated it to Axon Framework 4.10.1 with the newest Axon Server and the newest AxonIQ Console. And this is the... No, wrong button. This is the Auction House demo. The Auction House demo is a high-speed demo in which simulated participants want to buy and sell items of each other in order to make money. When it's running optimally, it can run at about 12,000 auctions per minute. And it's really a showcase of the power of Axon Server and Axon Framework, especially if you combine it with observability tools. However, as you might have noticed, we have a long list of auctions here and nobody bidding on it. We have important KPI metrics defined, such as the unconfirmed bids. That's people that have bid on an item, but have yet to receive an answer if their bid was high enough, or that it was failed, or whatever. We also see a lot of users waiting for data, and that even users are still waiting to receive the object they have bought. And sometimes some bids come true, but it's just not the way we want to run it. As the auction house, we are losing money because we live on the commission we make on the auctions. So this is the perfect use case to hook it up to AxonIQ Console, which I, of course, have done. So this is the result of hooking up the application to AxonIQ Console. The Auction House demo consists of 5 services, which each have the role to play in the microservices architecture. Well, you might ask me, like, how do they connect to each other? What messages do they send? And this is something we can already discover with AxonIQ Console because it automatically instructs the code of your application to discover messages, to discover handlers, and see the performance of them. So one of the key parts of AxonIQ Console is the observability it gets you of your code running into production. And one of the important graphs is this one. It groups the different components in your Axon Framework applications together by application and then shows you the messages flowing between them. So you can see that the transfer of ownership saga is sending commands to the auction aggregate, for example. But you can tweak this graph to your liking. So we can even choose to not draw the aesthetics. We can choose to not draw the application circle or allow the nodes in the application circle to get them in there, and we can customize it to our heart's content. Right now it's a component diagram, but we can easily change this to show all the handlers in our applications and how not messages are flowing between components, but how messages are flowing between message handlers of components. So we can see that the query bus in interfaces is our, well, backend for frontend. We can see that it's sending queries. The get auction objects query, which makes sense. The users want to know the auction objects that are selling. So this is already one of the benefits you get from AxonIQ Console, but it doesn't solve any problems on its own. Right now, it shows the amount of messages. The amount of messages divides the width of the link. But we can change that. We can say, all right, we want the slowest handlers to have a wider link, and we're going to change the scale. And now we're going to see that certain parts of our application are definitely slower than others. And we can investigate them in AxonIQ Console and fix them. So when we look at an Axon Framework application, we have different components. We have processors, which are represented in this tab. We have aggregates, which are represented in this tab. We have handlers, so these are individual message handlers. And of course, they are running inside an application. And we'll go through the screens one by one. I know they flashed by. You didn't. It was just to get orientated. So if we go to the processors tab, we can already see some warnings showing here. And this warning is also being shown on the start page, which is our monitoring. And if we open this processor that has a warning, we can, in the overview, we can already guess what's happening. We have a latency here of 18 seconds, which tells me that when an event is produced in the aggregate, it takes about 18, well, now 25 seconds until the data is visible in the database. We can see this latency over time as well. We can see it sort of going back and forth. In the demo application, this kind of makes sense because auctions only last 10 seconds. If you only see an auction after 25 seconds, that means the auction already ended 15 seconds ago, so you cannot vote. That means that less events are coming in, it catches up, it gets some bits, and it goes into this wavelength again. Now, we can probably figure out what happened. So we know that we have one instance running of this processor, that we have one segment running, and segments are the way that Axon Framework parallelizes work. So if you have one segment, you can handle one message at a time. If you have 16 segments, you can handle 16 at a time. And we can see which event handlers have which performance. And we can see that AxonIQ Console already singled out two handlers that are very slow at the moment, the auction ended event and the bid placed on auction event, which are two very important events, and they're way too slow. So what do you do if you only have one thread and your process is really slow and you don't want to change any code? You parallelize your work. And this is done through the event processor management of AxonIQ Console. We can split the amount of segments, parallelizing the work. Now, with this kind of performance, one split to two segments will already help. It will get a higher throughput, but just two segments probably won't be enough for such a serious performance problem. So let's take a look at the automation tab. In the automation tab, we can enable AxonIQ Console to automatically scale the number of segments for us based on the number of applications. So let's say I scale and balance the segments, and I set it to 16 segments. It will create 16 segments for each instance that is connected. So do I have one instance, it will make 16 segments. If I have, well, quick math, 6 instances, it's like 128. And so you can automatically scale, for example, in Kubernetes, not only your instances, but also your segments, parallelizing the work. Now, this is a lot easier for me than clicking 16 times on split. So I'm just going to click it here, and we can already see it starting to extend the number of segments to 16. And we will see that the latency has also gone down considerably. We measure the latency of each segment, and this way we have now parallelized the work. So just to prove that this works, let's go to the auction house demo. We can see that since we have split the segments, in the graph here, we can see that the number of confirmed bits per minute has gone up. We're finally making money again. We're making bits. But whenever you're facing a serious performance problem and fixing it temporarily with more segments, you probably also want to fix it in real life. Because even though we are running at a more optimal speed, there's still a lot of unconfirmed bits. The numbers are still red. So let's tell our engineering team about this. So let's tell them about the issue. They told us to solve it our own, but let's try again with them. Our engineers found a problem processing bits in the auction query service where a regex on the participant's name caused slowness. Well, I've personally encountered this problem with a regex. Someone was being too smart in the company and made a very huge performance problem. So let's tell our engineers to fix it. Well, in the real world, that probably would involve a lot more actions, but for the demo, I made this super nice fix-it-all button. I wish I had that in real life. And we can immediately say that the number of unconfirmed bits takes a dive, and the amount of confirmed bits go up. And this is what we want as the auction house. And we can also see this back in AxonIQ Console. So all these segments are now processing with 23 milliseconds, 2 milliseconds, 8 milliseconds. So this is great news. They get the confirmation of the bits in 8 milliseconds. This is what we would like. And maybe you would ask, why do you have two numbers here? In the real framework, in Axon Framework, we only have one number, the event processor latency, which is the time it takes for the event to travel from the aggregate to the event processor and start processing. That's all nice and well, but it doesn't matter the time it took for that event handler to process. And even worse, if you process batches of events, like 100 at a time or 1,000, the time it takes to be visible in the database might be a lot longer. So we measure both. We measure the ingest latency, which is the original Axon Framework latency, and the amount it took for it to be visible in the database. So we really know that if we had a command, and then that event that in 11 milliseconds, or 24 over all segments, that data is committed and visible in the database for your projections. So this will solve the alert, and now we have the automation here. Let's go back to our auction house and look at the demo, how it's running. So we still have customer feedback to process. They already say, well, it's better, but we need a long time to retrieve the auction. So I'm in line, I'm waiting on my answer to see which auctions are there. Can't you do anything to make it faster? So let's take a look at AxonIQ Console at our overview. So if they are waiting on answers on the query state, we probably want to look at the auctions query service, which is responsible for serving this state. We can see that we have 4 alerts here. 2 are still on the latency of the bit placed on auction event handler. I think these will disappear soon. We check these alerts every minute, and it takes a minute to go off. And we see that the query bus usage is greater than 100%. So let's take a look at this auctions query application. We can see we have 1 node, and that of the 5 slowest message handlers, by far the slowest is the get active auctions query. It's right there at the top, so we probably want to take a look at it. And we have seen this because the query bus usage is greater than 80%. Who here knows what I mean when I say query bus capacity? Okay, that's already more than I expected. Just to every application, every part of your application has a capacity. So for example, if you look at your database connection pool and you've configured that to 10 connections and you're using 9 connections, that means that you're using 90% of your database pool. So you're using 90% of the capacity. Axon Framework has something similar. Whenever a command or a query comes in, it puts this on a thread pool, this task. And if you're using 9 out of 10 threads, your capacity would be at 90%. And once it reaches 100%, people will need to start waiting for the query to be processed. And that's probably due to a performance problem or due to not enough threads being available or not enough database connections being available. And we can see that happening in this graph as well. The command bus capacity is fine. That's normal because this service doesn't contain commands, so it's not using any capacity. But the query bus capacity is very high. And that is because of this query. We can see we're handling about 1,500 of them a minute, but if they all take about 500 milliseconds, even with 10 threads, that is going to take, well, too much time. So they start waiting on one another. Now, let's tell this to our engineering team, what we just discovered. Let's hope they don't reject us this time. So they found a database locking issue with inserts and reading, and it prevents the throughput of the Axon query service. So, of course, I made a magic fix button. Again, we wish we had this in real life with database problems. And we can see that the users can now bid to their heart's content. They're buying and selling items. You can see them in the overview here. This one is selling his incredible concrete bottle, and it's trying to buy the heavy-duty bronze hat. They are silly names generated by a test data faker, but it does the job. So after processing the initial load of bits, it's going to recover now. But it's not doing that. The users are still saying it takes too long to receive our items. Like, we are buying items, but we have to wait minutes to receive them. So we can't sell them again and make a profit. So what's going on here? If we look at our message flow diagram, we see that we have the transfer of ownership saga here. This transfer of ownership saga does a few things. Whenever an auction gets completed, it will try to deduct the balance of the original participant, the one that bought it. If that succeeded, then it will credit this to the one that sold it, and then move the product over the auction object aggregate. Every auction object has an owner. And you can see this happening in the graph. You have the transfership of owner saga, sending commands to the participant aggregate, which has its balance. Then we have the participant aggregate publishing events. The transfership of ownership saga responds to that and sends commands to the auction object, which then updates the information. And this process is taking way too long, and all our products are in limbo. So let's take a look at the aggregates that are in the application. So we can see that we have 4 aggregates in total in our system. Or 1. Okay, this is interesting. So really quick, we have the auction object, we have the auctions, we have the participant aggregate, and we have the emo uniqueness aggregate. We can see that by far with 2,500, 2,600 per minute, the auctions aggregate is the most active one. But the one that's having problems is the participant aggregate with a load time of, well, I was able to see it, almost 2 seconds. So let's investigate why this is happening. Immediately when I open this, I see something that would shock me as a developer. Over the past minutes or time, we only see an ever-increasing graph of the performance. This will eventually grind our system to a halt, which it's already doing. The message rate is going down, we're seeing more errors, and this is a maintenance nightmare. AxonIQ Console allows you to really dig into the different metrics of the application, the aggregate, the event processor it's running in, and the handler itself. So if we look at this aggregate, we can see that the total time it takes is going up. So why? Well, whenever you handle a command, there are several steps in the process. You receive the command, you try to acquire a lock on the aggregate identifier, so you're sure you are the only one acting on that aggregate. Then you fetch snapshots and events from Axon Server, you hydrate the aggregate, you execute the command, you store the events, and you send a message with the result back of the command. Very simple. So each of these steps is something you can see in this graph here. So if we open this, we can see that out of all the steps, the actual handler time, the time our code is executing is 21 milliseconds, which is fine. The commit time into Axon Server is 2 milliseconds to store an event, which is awesome. Then we have the lock time, 0 milliseconds, so locking is not a problem. And we have a load time of 1124 milliseconds. We probably want to take a look at that loading. So yeah, we can see indeed that the load time is going up. And here we can immediately see our culprit. The amount of events is ever increasing. And this is one of the problems you often hear in event sourcing, like, hey, you're storing all the events. Will that not, in the long run, make your system slow? How do you handle aggregates with millions of events? Well, I don't know. Let's ask our engineering team. Of course I know. Oh, and the engineering team opened the excellent Axon Framework documentation, and they saw, like, you probably want to enable snapshotting. We are loading all the events all the time, but we need to, well, reduce that stream. So we need to make snapshots of our aggregate through time. So we can, for example, load a snapshot from index 1000, then load the last 20 events, and that will give us our aggregate. He also said, but Warren, the first minute or so, the performance might go down because you need to first make those snapshots. So the first command will trigger the creation of the snapshot, and then it will actually be there. So let's do that. And of course, I made a magic button for that as well. And now we will start seeing that the unsettled objects is going to be slowly decreasing, and that means that people can sell their objects again. So we're getting like a gazillion confirmed bits per minute. And this is actually the state we want our auction house to be in. It will take a little bit of time to recover, but our users are happy. They can buy the items, they can see the items they want to buy and sell. They are getting their item in a reasonable amount of time. And, well, if we leave this run for a little bit, it will be completely all right. And we can confirm this in AxonIQ Console as well, that the snapshotting is working. We can see the event stream size, immediately the minimum taking a dive to 0, and the median going down, and the maximum, well, for a minute or so, because the metrics expire after a minute, it will start going down as well. So we have successfully saved the auction house, and we can see that actually happening here. At the last point in time here, in total, our our average times here, the commands now execute in 14 milliseconds instead of over 800. And this is the way we want things to be. Now, I already introduced you for a little bit to the alerts. So any statistics you see in AxonIQ Console is alertable. So you can define threshold on either all processors or one specific processor, that if you have a very high latency, that you get a Slack message. Yeah. And you can configure that here with the conditions in the screen. So you can say, when the error rate is above 1% for 10 minutes, I want to receive a Slack notification. So we've really tried to make it easy for you to observe, fix, and visual your Axon Framework application. Now, this entire demo was powered by Axon Server, but one of my Axon servers is online and I see warnings in my monitoring interface. Let's go to the Axon Server interface and find out what's going on. Yeah, this is our new Axon Server UI. I've personally not worked on it, but my colleague and his team have, and I want him to tell you everything about it. Welcome, Stefan Dragisic, por favor.
Thank you, Mitchell. Yes, that's right. So we couldn't let console is the only to have cool new UI. So we want to build something, and it was a good time because Axon Server was 5 years old at the time. So we kind of grown out of the skin with all the features and information that we were showing. So we wanted to sit and to design it from the beginning. But first we want to understand what the users like and what users hate. And something big happened in my personal life at that time. So that completely threw me out of the track. So my supermarket, when I buy every day, completely changed the order of all the shelves. I go there to buy a milk and I spend 30 minutes searching for it. And that was the first clue. We don't want to change the order. We want everything to be where it was, where people remember it is, so they can easily find their way in the new UI. The next thing that we were trying to figure out what people like, what people love, is functionality and useful information. So we were thinking, okay, what we can do? We can simplify things, that they can understand important information easier, and we can make information more visualized. So the first thing that we wanted to rework is the overview page that everybody loved. It showed really quickly information about your cluster and what is happening. But it was not scalable. You have a lot of nodes, a lot of applications. It kind of grows. It's not easy to read, and it was not filterable. So you can click your application and see where it's connected to which Axon server node and which context. So we wanted to make that super fast. So you can just hover any node, and it can only show you the dependencies where it's connected and what it's using. But you can also click on the filters and make that permanent, not only by hovering. And now we hid some information from you. Before you entered the page and you see all of this information, this is the host name, this is the port, and now we hidden this, so you can now just click the node or application and find the information that you had before in the new place, only when you have it. So you're not bombarded with a lot of information for the beginning. Next to that, we invested in use of ease, how it's called. How to make your usage of Axon Server easier. So we introduced some small features like dark theme, which was important, and the support for the wide screens. So if you have a
Applause, everyone!
most requested feature, and the support for the wide screen. So you have a large screen, you want to make use of it to fit more information. There is a neat little button on the top to do that. But we also really wanted to make users aware of any issues as early as possible. So we added this neat small check engine on the top, which only appears if you have any issues. So here we can see that there is a problem with the cluster, and we will shortly try to understand what is the problem there. So maybe we can go to the monitoring page, which is a completely new page.
Monitoring page?
Yes,
really?
It's right below the overview.
Ah, nice.
So this is a completely new page. And we understand from your usage which information you use the most. So basically, Axon Server is immutable event store, so it's using a lot of disk space. And you need to know early if you're going to get out of the space. So we added this information. We added the CPU usage, memory, something that frequently is needed. Next to that, we have this health page. And if you click any of these bars, now you can see basically what is wrong. So it's Axon Server 3. But you also have option to download the diagnostic package. And it's going to contain all of the logs, all of the thread dumps, everything that you need to understand what's the current issue. But next to that, we can quickly check the logs, because people quite often do that, and they need to wake up the sysadmin in the middle of the night, and we don't want them to do that. So we can just type logs here and quickly see what's the problem. So if we check it briefly, it's the host name. It cannot be found. So Mitch will fix that later. He will restart the Axon server and everything is be fine. System task is something that people can mess with configuration, like you configure the wrong host name, like here, and it's trying to register a new node constantly, and you don't know what the problem is. And here you can find this info, you can see what was the problem, and you can cancel this action and to fix it and restart the Axon server. Other improvements are regarding the searching your event store. So pretty important, because all of your data is here. So we wanted to be really easy to use and to add some features that you didn't have before, but you requested. So most importantly, export view. So now you can export all of the events that you currently have in the search, and that was not possible before. So before you needed to make your own projection to export this, and this is really a quick way of getting your events for later analysis. Next to that, we added some small features that make it easy to search the event store. Like you can hover any field, and you have these two buttons hovered. One is if you click it, it's going to automatically compose a query to search it further. For example, you can now search all the events for this aggregate. But you can also click the copy button if you just want to copy the details of this field. But if you click the action button view, then you have all the information, and it's nicely formatted so you can understand the payload of the event and what's happening. And you can click the copy and copy all to either copy the whole event or just some fields. Next to that, so what we added as well, Mitch already clicked it. It was this hamburger button just to get even more space, so you can have a lot of, that's it. There is search, so there is one request that why we removed the documentation for the search. It's not removed, it's in all of the pages we wanted to embed the small documentation. It's always available in this small info button next to the title, so now you have even more information, some even more useful queries how to use your search event store. Next page that we reworked a little bit was context. And we decided to hide replication groups here. So before it was in front of you and everybody's asking what is this, what is this. So it's, unless you're an advanced user, you probably won't need it. So that's why it's somewhere on the back, but easy to find still if you need it. So we can see a small graph here with events. This small graph only appears if you have active context, live information, and the event token is increasing. That means that events are being actively added to the event store. And you can now see how many events we have, and you can also see the size of the context, something that was really useful, but we didn't have it before. So you need to go to the folder, check some Linux command, and then it checks how large is your event store. Other notable things that we added was for the commands, if you go there. Before we had this large matrix, so you just open this page and large matrix, a lot of numbers appears like you're in Neo, and it was not really understandable. So we wanted to make this understandable, and we wanted to think how we can do that. One way was to introduce the heat maps. So let's color the commands that are sent the most. So you now have the option to see which commands by which instance are sent the most, which are handled the most, and distribution between applications. So which application is sending most and which one is receiving most. That's really important just to make sure your routing between applications works fine and there is no too much contention on one application, one other is doing nothing. Next to that, you can always filter these fields, hide some commands, or you can even download this whole graph just clicking on this hamburger icon. You have some live useful information like what is the average latency of the command, how many active commands, that's how many is currently being in the queue processed by Axon Server, and how many are executed since the start of Axon Server. And really important, how many commands failed with some error. We also had this small view on the bottom, which is long-running commands. So we found often that users make mistakes like doing really long tasks in the command handlers, which is kind of a bottleneck, and it prevents your whole aggregate processing other events. So we really wanted to find this information if something like that is happening, and to show it to users. Like this command is being really slow, it takes more than 2 seconds, and you can cancel it if you want. Maybe it's taking 10 minutes. You can cancel it, you can see, and you can go to the event handler, to the command handler, and to understand the reason why it's being slow. Similar story is for the queries. We just have a different view for subscription queries here that you can see all the stats about subscription queries. But all the fun is actually in the new events page. So it was kind of weird, it was event store, but there was a command and there was query page, but there was never events page. So we found that it's really important to have events page and to have really good information there. First, that what we added is UI for the scheduled events. And that was also really weird. So we had this feature for a few years. And if you schedule events, you cannot see which events you have and when they're expiring, did they trigger with the error or not. So we really needed to show this information. So you can now go to the events page, to the scheduled events. You can see all the events that are scheduled, and you can cancel them if you want. And you can even see the payload and the status, if it's scheduled or did it fail for some reason. But next to the scheduled events, there is a really important tab, which is streams, and it's currently empty. So maybe my colleague Stefan can help me with this one, because this is a really important feature that we added previously.
Thank you, Stefan, for pulling me on stage. How am I ever going to beat all this UI goodness? You know, in Framework, you just have a library that you use. You don't have the fancy things, so this is an unfair advantage that you guys have over me, but I'm still going to do my best. So I prepared some specification for you, so if you could put that in.
Here.
All right. Thank you very much. So, before we dive into what this streams page was, I want to start with a bit of a basic, what this really is. What does it mean to handle events? And I think this breakdown is very helpful of the components that you typically have. So you have some kind of a source where your events are coming from. This might be your event store, this might be some kind of bus, who knows? You got an event consumer, this receives the event. This is where you have your technical concerns. So this is where you do the sequencing, the threading, the error handling, all that stuff lives in that component. Then there is a event handling component. This is where you would implement your business concerns. So when you're using Axon Framework, this is typically the thing that you write with the event handlers in it. That is the event handling component. And in most scenarios, you're updating some form of a projection store. So you got a query model that you're storing and updating that's going to be read. So this is a very typical scenario. Now, for those that are using Axon Framework, you might know there's a little bit more to it than just this. By default, you would have a streamable message source or a streamable event source, because events flow out of that. And those are streamed towards a streaming event processor that streams the events to the event handling component. Next to that, a new component comes into play. This is the token store. This is where you keep track of the position in the event stream. So the streaming event processor reads the events or wants to know where it was with handling events. So in case of a failure or you need to restart it, that it goes back to that point in time. You need to store that position somewhere. So this is why you would typically have a token entry table compared or combined with the query model in the same database, because you just want that to be a single transaction. That makes it simpler. Well, you don't want to have distributed transactions, don't we? So, this is nice, I guess. But we can simplify this, I think. So, let's assume our event source is Axon Server. If we have Axon Server in here, I think we can get rid of the token store and the token entry table. And this is what that stream page showed, the new feature called persistent streams. When you're using persistent streams, you don't have that token store anymore in your Axon Framework application. You don't need the token entry table anymore in your database. You'll just throw them out. You don't need those. This does require a little bit of a change though. We're not using a streaming event processor anymore. We're switching to a subscribing event processor. The subscribing event processor subscribes to Axon Server to get the stream of events, and an Axon Server will take care of the position and the tracking. So we can change the diagram a bit further. We just have to stream over there, the subscribing event processor, and simplify our setup. This has a couple of advantages. Next to that, well, it obviously simplified the setup, so you don't need to deal with that logic of having a token entry table that's constantly updating as well. I actually got a question about that yesterday. What is this query I see happening all the time? Well, there's the streaming event processor always updating its claim. You just lose that logic altogether. Another one, which I find very important, is a freer choice of storage solution. When you were using a streaming event processor, you needed that token entry table to keep the position. So if you wanted to use something like Neo4j or Elasticsearch or some other kind of database for which we did not provide a token store implementation, you would either need to have a relational database next to it or make your own. It's not very friendly, right? So you can just, well, get rid of that altogether. Furthermore, a question we've also got quite frequently, I don't want to store anything. I don't want a relational database. Sometimes you just have that scenario. You don't necessarily update a projection at all times. You're just, well, going through some third-party service, or you're just keeping stuff in memory. And that is now also an option by using persistent streams with Axon Server. You just let Axon Server do the tracing for you. That's it. So I hope I did my best a little bit on battling the UI fanciness from Mitchell and Dragisic there. I do have a little bit of code. You're using a Spring Boot application, right?
Yeah, definitely.
Okay. So in that case, the configuration is rather simple. So the top part is what you would have if you're configuring your event processor. So you have the processor name, you need to tell it that it's subscribing. because you need to switch it to a subscribing event processor, and you need to tell it what its message source is. So in this case, well, the stream name. The stream name is something you would define on your Axon server properties. So you would give it a name. Well, in this case, we call it persistent test. And there are some other things you can add. There's more to it, by the way. If you're curious, you can come to the overflow workshop that's in the big room downstairs, because we actually did a workshop to use persistent streams together with multi-tenancies. You get a little bit of a feel and see what's more to it. In our case, typically you want to deal with the segment count and some form of the thread count. So can we actually use this in the auction demo? I think that would be nice, right?
I think we can.
Awesome, thanks.
Let's see. Let's copy this over because I don't really want to type.
Yeah, sure, go for it.
And then I go to the best UI there is, IntelliJ. So let's copy this. I think, what was the name of the projection again? It was the auction objects projection, right? Yeah, so it's called auction object. So this will also be the name of my event processor, right?
Correct, correct.
Right, so let's fill that in. I have processor underscore name here. Gonna call it auction objects. And then stream name can be anything I want, right?
You can keep it stream name if you want.
Awesome. Goodness. And then the persistent test is gonna be persistent is awesome. And then all that's left is to reboot the application, right?
Correct. Just a reboot should be sufficient.
The object registry application. Rerun. Let's ignore this. All right. So did it work?
Looks like it to me.
All right. Let's see in the auction, in the Axon Server UI. It did. So now we have this persistent stream, but I have way too many events. Can I speed it up?
Yeah, you can speed this up. If you go to the dial over there.
Persistent is awesome. Segments. Well, we had 32 threads, right?
Yeah, we said it. Yeah, just put it to 32. Should be sufficient.
I don't need database connections anymore, so. Now I have 32 streams.
Cool, right?
Very cool. You promised me it's really faster?
Should have been. But your machine is doing a lot right now, right?
Oh, yeah, it is. And
maybe
I didn't even boot the third Axon server yet.
No. It's just...
No, it's okay.
Yeah.
We'll leave that for another presentation.
We'll fix that later.
But if I want to go from the start, I can reset it here, right?
Yeah, you can also do a reset note at this point. Yes.
Let's just skip ahead and go to the last index. Let's reset it. Done.
Woo!
Right. Thank you for all the information. This is awesome. I can get rid of my token store.
Yeah, right. This is cool. Yeah, this is all I wanted to show, so thanks.
Oh, thank you very much. This was the AxonIQ's latest product demo. If there are any questions or later in the room, any feedback you would like to provide to us, we're happy to take it and put it into our product. So, are there any questions? Yvonne.
Is it the old-fashioned subscribing or event processor that you used?
Yes. This is the old-fashioned subscribing event processor that everybody thinks is happening in the same thread as the event you're publishing. And that is, well, in this case, not true. Because you're changing the subscribable message source in this case. Because it switches from a streamable message source to a subscribable message source. And the persistent stream is an implementation of that. So it's that implementation that has the logic of threading and segmenting and all that goodness.
If I would have happened to have an application that is not Spring Boot, is there some documentation how to configure that?
Some. Definitely API docs, the Java docs, because no review gets past me without Java doc. And if you do see one, please wake me up at night. But no, that's still a task we have to do. It's on the list, but yeah,
I may add, I opened a pull request for that and an issue, and I'm working on that. So if you want to contribute, so we try to come up with.
Thank you, Jacob. Nice.
Always nice to see people working on our projects as well. Someone actually told me as well that they're working on an Axon Framework extension for Quarkus. So you can just use your Axon Framework with Quarkus without any problems.
Very good.
Yeah. So nice to hear.
I saw that you did lots of configuration changes in the interface. So if you have a whole IT team doing configuration changes all day, like, is there anything infrastructure as code style thing to manage and persist these configurations as code?
Which configurations are you referring to? You're referring to the application properties or to the AxonIQ Console configuration?
To the AxonIQ Console and the Axon Server configuration. So maybe some Terraform or something. I don't know.
At this point in time, it's not in place yet. We do have it on the roadmap, but I can't promise you when. It is a much requested feature though, because a lot of people are using Terraform with good reason. And it would be really nice to automatically be able to create AxonIQ Console access tokens. But it's not there yet, and I don't have a definitive date.
Neither do I.
All right. If there are no further questions, then yeah.
Thank you very much, gentlemen, and I hope you enjoyed. And